So what you really want to be able to do is use the quotient rule to find derivatives of functions like this. So by the way, if you're in calculus class in college and you see this derivative, and if you say p prime of x is equal to e to the x over 2x, in other words, you just do the derivative of the top and the derivative of the bottom, your calculus professor is going to right away know that you don't really know calculus semester 1 very well, because it's not that. You cannot just take the derivative of the top and the bottom. So make sure you don't do that. If your calculus professor says, what's the derivative of e to the x over x squared? And you say, I know there's a quotient rule, but I can't remember what it is. I would need to look it up. All right, your professor will respect that much more than if you do this. If you do this, you're showing that you don't even know that there is a quotient rule. All right, but if you say, I know there's a quotient rule, it's something like there's a numerator, there's a g squared somewhere. All right, at least they'll say, oh, yeah, you're sort of on the right track. This is the quotient rule. Now use it. All right. So, but ideally, you will have both the product and the quotient rule memorized. You will know them. All right. And that memorization comes best from frequent application, which is why I give you lots of homework on it. So what you want to sort of bear in mind, sometimes it's useful to me to make a little chart up here. Here's f, here's g, and then f prime is e to the x and g prime is x squared. So this isn't saying what the derivative is, it's just a chart that I use to organize my work. So then I know that it's f prime g minus fg prime over g squared. See, it makes sense that if you drop the denominator and change this to plus, then you have the product rule. That's why I like to write them in similar order. All right, so if you write the rule every time that you use it, that's what I like to do when I'm learning something. I just write out the rule every time I use it. Then once I've written it, like, for 10 problems, I will remember it, and I won't have to sit there with a flashcard trying to memorize it. So I like to memorize things by using them. So what's my f prime is e to the x, and then I have my g, which is x squared, and then I have a minus sign, and then I have my f, which is e to the x, and then my g prime, which is x squared, over g squared, which is x squared squared, which is x to the fourth. Did I do something wrong? G prime is 2x. Look at that. Look at this nonsense here. So nobody's going to respect me if I can't write the derivative of g prime. Derivative of x squared is 2x. So this g prime should be 2x. Fortunately, that's the only time I use g prime in this formula. E to the x times 2x, okay? And then, you can reduce this as long as you know that x is not equal to 0. I know x is not equal to 0 in this function because x equals 0 is not in the domain of this function because it would make the denominator 0. Therefore, I can reduce out the x. I can factor out the e to the x. So I could have, for example, e to the x times x minus 2 over x cubed. That's the derivative of e to the x over x squared. All right. What else? I just make stuff up. Let's have p of x be, I know, sine x over cosine x. All right. So then sine is f, cosine is g. F prime is cosine. G prime is negative sine. Don't forget the negative when you do derivative of cosine. So if I wanted to know what the derivative of that is, that would be, I said I was going to write it every time, so let's do it. F prime g minus f g prime also gives me a chance to stall. So I can go, what am I doing? I can't remember what I'm doing. I'll just stall by writing the equation. Okay, so f prime g. See now with this too, you can go like f prime g minus f g prime. So if you're a spatial thinker, f prime g minus f g prime. All right, it's got a nice rhythm to it too if you're musical. So I'm going to have cosine x for my f prime times cosine x for my g, and then minus f, which is sine x, times g prime, which is negative sine x. So times negative sine x. That's interesting. And then over my g of x squared, which is cosine x squared. Cosine x squared. Okay, so this one simplifies a lot because I've got cosine squared, and then minus negative, that's going to be plus sine squared over cosine squared. Okay, what should I do to simplify this? What should I do to simplify that? Cosine squared plus sine squared is 1. You should always recognize that. So I have 1 over cosine squared. All right, what's 1 over cosine squared? Give me a reciprocal function. It's secant squared. All right. Now, hey, look at this cool thing. Sine of x over cosine of x is tangent of x. So that p prime of x is really the derivative with respect to x of tangent x. So now you know another new derivative. The derivative of tangent is secant squared. I wonder if we can find other derivatives like that. Why don't you use this process right here and tell me what the derivative of cotangent x is?